A VPN, or a virtual private network, allows us to have secured communications over an untrusted network. So it's a point-to-point encryption tunnel through which traffic that might normally not be secured is protected because it's going through the encrypted tunnel. Remember when we talked about IPsec and we talked about packet encapsulation? Well, that's really what's happening with the VPN. Not to say that VPNs have to be IPsec based, because they don't. But imagine that we've got an original packet that needs to go over the internet in a secured manner. Now, whether that original packet is encrypted or not doesn't make a difference. If it's already encrypted, then by putting it within a VPN tunnel, it's double encrypted, you could say, so protected even more. Then we can send this encrypted packet over the network to the target where it gets retrieved to its original form. So we're talking about having network security to allow remote access to a network in another location. That's really what this is about. Now, authenticating to a VPN can happen in many different ways. So let's say, for instance, we've got a tablet that we're using as our VPN client device. It just as well could be a smartphone, it could be a laptop, a desktop, whatever the case is. It needs to authenticate somehow to be allowed to establish that VPN tunnel. So one of the ways that we can do that is by simply supplying a username and password. We know by now that's not considered secure because it's single factor, something you know. But we could enhance that authentication in terms of using multi-factor authentication, maybe requiring a smart card along with a PIN, or maybe requiring the device to have a PKI certificate that's trusted by the other end of the VPN connection. We could use maybe a hardware or software token, a physical device that has a changing code that we must enter in to authenticate to the VPN. Maybe we need to insert a smart card into our computer before we can get a VPN connection. There are so many ways to authenticate, but anything is better than just username and password. Now, there are a couple of different VPN tunneling protocols, one of which is called L2TP. It stands for Layer 2 Tunneling Protocol. And if you're wondering, is that Layer 2 of the OSI model? It is. So the idea here is this is just a mechanism for establishing the tunnel over an untrusted network between two endpoints. But L2TP needs some way to encrypt the traffic, and normally it uses IPsec. It doesn't have to. And that's why often you'll see tunneling protocols shown, for instance, as L2TP/IPsec. We can also have SSL or TLS type of VPNs. Now, we're not going to call it SSL because we know that SSL is deprecated and that we should not be using it. We should be using TLS version 1.2 and better as we get new versions. But what this means is that we have a firewall-friendly VPN solution. Why is this? Because it's using port 443. So if a user is working from home and needs to connect to the company's VPN, and it's a TLS-based VPN, their home router probably already allows outbound traffic destined for port 443, because that's what HTTPS websites listen on. So it's firewall friendly. Whereas when we look at L2TP type of VPN connections, there's a bunch of UDP ports and IP protocol types we have to enable in the firewall to allow that type of VPN traffic. So this is called a TLS type of VPN. It's firewall friendly, and the way it works is the client would use a web browser through which they would then gain access to resources that actually exist on the remote network. And in some cases, the client might need to be using a new version of a web browser that supports HTML5 in order to partake in a TLS type of VPN. Now, one type of VPN is a client-to-site type of VPN. This is where we have an individual client device that is making a connection to a remote network through an encrypted tunnel. Now, in this case, it could be for users that might be working from home, users that are traveling, users that are at a customer site but need to gain access to our corporate network over the internet. So the client device then would require a VPN client software installed on it. So if we look at our diagram, we have VPN client software. For example, in Windows, we could use the built-in supplied Windows software to establish a VPN connection. Or if we're using a vendor-specific VPN solution, maybe we would have the Cisco VPN client installed. Whatever the case is, the concepts remain the same. So we would have an encrypted tunnel then between the VPN client and the VPN appliance on the remote network. So the traffic is encrypted for sure between those two endpoints. But after that, on the other side of the VPN appliance on that network, the traffic is no longer protected, at least not by the VPN. If the original traffic was encrypted that originated on the client endpoint device, well, it's going to still be protected or encrypted after it goes through the VPN. The idea is that we need to have connection to resources on a remote network as if we were actually there, but we're not physically there. There are some configuration options when you enable a VPN. One of those options is called always on. What this means is instead of powering up a device, spawning the VPN client software, and then connecting to establish the tunnel, instead, when the device is turned on, the VPN is configured to trust the device, the tunnel is already established. Now, the user still might need to authenticate. It might not be just device authentication, but that's what we mean when we say always on VPN. The great thing about that is it makes it very easy for sysadmins to apply updates. If you've got someone that's working from home or traveling a lot, they're not at the office with that device. So how do you patch it? How do you control that centrally? It's going to be difficult unless the VPN is always connected. You can go back through that connection to the client device and, for example, install updates. So that's a benefit of always on VPN configurations. Then there's an option called split tunnel, and it may or may not be enabled. It depends how you configure the VPN. What it does is this. Let's say we have split tunnel VPN enabled, and we've got a client working from home coming into the company network through the VPN tunnel. Great, it's secured, everyone's happy. When that client device makes a request, let's say for an internal web app on the company network, that connection will go through the VPN tunnel, of course, naturally, to get to that resource. But on that same client device, while the VPN is active, what if they surf to a standard website out on the internet? How's that going to work? Is it going to go through their home network connection to the internet, or will it first go through the VPN tunnel at work and from there go out to the internet? How is that going to work? Well, it depends on split tunnel. If split tunnel is enabled or turned on, then when a user is trying to connect to a standard internet site, it's just going to use their home internet connection. But if they try to connect to work resources, that goes through the VPN tunnel. Now, some organizations like to have all centralized control. In other words, when a user is connected to the VPN, anything they're doing on the internet goes through the company firewalls for inspection. In that case, we would disable split tunnel. So you might get an exam question for Security Plus related to a requirement, like I've just described, which means it would be testing your knowledge of when you should enable versus disable split tunneling in the VPN. So we've talked about a client-to-site VPN. We can also have site-to-site VPNs, perhaps to link branch offices over the internet in a secured manner. So in this case, each site would need a VPN appliance, both networks. In the case of a client-to-site VPN, only the target network needs the VPN device. So what happens then is the tunnel gets established between the two VPN devices at each of those locations. Now, if we look at our diagram, this is interesting. With the site-to-site VPN, we're linking office networks, let's say. So on the left, we have a site that we're calling Site A, and on the right, we have a site we're calling Site B. Makes sense. So what happens is that we've got two VPN appliances, and the tunnel is established between them. And maybe that tunnel is authenticated through Kerberos, through a PKI certificate, through a pre-shared key, in other words, a symmetric key. Who knows? All that stuff still applies here. But what's interesting is that client devices on either Site A or Site B's network, they don't individually need VPN client software. Instead, through the magic of routing, when they go to access a resource on the other side of the VPN, through routing table configurations, that will automatically happen. So we don't need VPN client software configurations in a site-to-site VPN environment. And normally this is done so that the site-to-site VPN tunnel is always up and running. So for the Security Plus exam, make sure that you know the distinction about what's required when you're configuring client-to-site VPNs and site-to-site VPNs. For example, client-to-site VPNs means you need VPN client software configured to establish the tunnel.